What I'm going to do now is I'm going to prove why an inscribed angle is half its intercepted arc. This is by request from actually 2 or 3 students. So we're going to start off, I'm just going to do a walkthrough or talk-through proof. I'm not going to label the 2 columns and give every little definition. I'm just going to walk you through it. And we're also going to do the one where we have an inscribed angle where we have a diameter as one of the raised chords or lines or however you want to talk about it, and another one just shooting off in another direction. So here's my inscribed angle going through the diameter. And the reason I did this one is because this one builds upon the other different scenarios. To prove it for the other ones, we would actually we would add on and build a diameter and stuff like that. And the reason for that is very important because look at what this DC segment is. That's a radius. So it's this BD. This is a radius. So we're going to use this concept because our theorem states that this intercepted arc right here is double this angle. Let's try and prove it. So what I'm going to do is I'm going to draw another radius. So here's another radius. I'm going to use a little dash line with sound effects. Okay, so this is a radius. Now notice I don't have any numbers on here because that's one of the things we do in proofs. We often don't put numbers. So this is a radius and this is a radius. I want a different color. So these are both radiuses. That means these are both the same. Okay? If they're both the same, I have an isosceles triangle. That means that we have this angle and this angle, base angles, are also the same. So we have these 2 angles is the same. And we have a radius here and a radius here. Now looky here. This is way cool. We have another radius right here. Here's a radius right here. That means this is equal to this and this. So these distances are the same. Now we have a central angle also. See this central angle? By definition, this angle right here is equal to this. So call this angle 1 is equal to the measure of arc 1. All right? So this is the same as this central angle. Now here's the kicker from last semester. We have a triangle. 2 remote interior angles are equal to its exterior angle. So this angle 1 is equal to these 2 added together. Very, very important. Or as they say in Spanish, muy importante. Did I get that right? Okay. So if these 2 angles are equal, and they're also equal added together, these 2 angles equal to this one together, then half this angle, one of these angles is half this right here. So this is, say, call this angle 2 and angle 3. Angle 2 is equal to 1/2 of angle 1. All right? So angle 2 is equal to 1/2 of angle 1. Because these 2 angles are equal, both these added together equal to this one. And the way I kind of drew this almost made it look like a 45-45. So these 2 angles added together equal to this one. This one is equal to this arc. Therefore, this angle is equal to half the arc. That means this angle right here is equal to half the measure of this arc. And that's a walkthrough proof. I didn't label and do my little 2-column proofs or anything like that. But that kind of explains why this is half of its intercepted arc. When we have different scenarios, we use this proof and add a couple more layers to it to explain different things like when we don't go through the diameter. Alrighty, so that's pretty much it. Okie dokie.